Hello again, students. It is Mr. Mace, and I'm here today to walk you through Unit 3, Lesson 9. Again, kind of a continuation of what we did yesterday. So if you watched the video yesterday or you were instructed by your teacher yesterday as to how to find those common denominators, this is going to build upon what we covered in yesterday's lesson. Now, we are going to get much more in depth into it. We're going to show you the different ways to kind of find that least common denominator, that smallest denominator. Do a little bit of work up front so we have less to do with the simplification on the back end of our problems. And again, to each their own. Everybody has a little bit different way of viewing this, but I think as teachers, we really find value in getting students to find that common denominator, the smallest common denominator, right away, because then it makes for easier adding, it makes for easier multiplying, and those kinds of things moving forward. All right. We are going to break this lesson up into 2 videos, so just be aware of that. We are starting on page 137, and we're going to go through page 139, but that will be for both videos. This video will probably just make it through page 137. At the way it looks. All right, so we can see here on the top of page 137 that we have 3 different ways to make common denominators. They call them cases. We've got case A, case B, and case C. Okay, and in my opinion, they kind of work their way up in terms of difficulty or in terms of how much work I have to put in to try to find that least common denominator. If I look at case A, it is one denominator is a factor of the other, and that's going to be this first one right here that I've circled. That is an example of case A right there, where if I look at 8, if I look at my larger denominator, I should see 4 in my factor list for that. 4 times 2 equals 8, meaning I can leave the 8 alone and I can simply change this denominator 4 to an 8, and then I get by with only having to change one fraction, and I can leave the other one alone. That's, again, in my opinion, the easiest one, because I only, in the long run, need to change one denominator. That saves me a lot of time and energy. Case 2, or case B, I should say, the denominators have no common factors other than 1. And that's an example of what we're looking at in this second one right here. So I would put that in this column where I'm seeing numbers, and I know in this case they are case B because they're one number apart. And if I look at that, 3 is not a factor of 4. And because they're one apart, I'm going to skip count through their patterns, through their multiples. And the first one I'm going to come across is 4 times 3, is multiplying those two things together. Now I can go through all the hoops, I can line up and skip count until I get to that 12, but hopefully we can start to recognize these things just by creating that number sense. And like I said before, if the numbers are one apart, if my denominators are only one away from each other, it's a guarantee. There is no way for me to create a denominator smaller than just multiplying those two numbers together. So in that case, the denominator for both of those would be 12, because the only way for me to change 4 and 3 would be to make them a 12. So they're going to go in category B, or case B, where I'm going to multiply the two denominators together because that is still going to give me the least common denominator. And then the last one is case C. And this one is, I think, the most confusing. The hardest one to imagine and picture for students. This one really comes from multiple lists and creating skip counting patterns of the two numbers involved. And that is going to be an example of this third one right here going into case C, 4 and 6. And here's what I mean by that. If I start skip counting by 4, I work my way up this list, and I'm going to go up to 20. That's 5 examples. And then I'm going to skip count by 6s, because those are my two denominators. And I'm going to stop at 24 because I know I've already moved past, and I see a number that doubles up on both of them. If I'm able to create a multiples list or a skip counting pattern list for those two numbers, I will find a number before multiplying those two numbers together. If I multiply 4 times 6, hopefully you guys recognize that that is 24, but I can also find a 12 in that list before I get to 24. If I extended the 4 out one more here, you'll see that 24 is a common multiple as well. It's just not the least common multiple. And like we said, sometimes there is an advantage to finding that least common multiple or least common denominator. It's going to make our lives that much easier. Okay, in the long run, and at the end of the problem for sure. So Case C would be something that is along the lines of a 4 and a 6, where I'm still going to need to change both fractions, but I'm not choosing to multiply those two denominators together. It just it's going to create too large numbers. So as I look through the rest of my patterns here, I should be able to determine which of these number patterns go into which case. So for me, the next one, I'm going to change colors just so we can see that those are no longer the examples we're using here. So I'm going to change to green, 5 and 10. Okay, that again should go right back like 4 and 8 was, where I can see that 5 can easily be turned into a 10. And I can leave that 10 alone, and I'm only going to need to change that one denominator. I can easily change that denominator of 5 to a 10 by multiplying by 2. So that is a case A. All right. And then again for 5 and 7, just like the second one in our pattern with the red ones, they're two odd numbers. If I start skip counting by 5 and I start skip counting by 7, the only way I'm ever going to run into each other, the only time I'm ever going to find that common number is when I multiply those two together. So that is an example of case B, where I have to multiply the two denominators together, and it's going to give me a larger denominator, but that is still the smallest common denominator that I can come up with. And then the last one here, 8 and 12, would go into case C, because as I look at 8 and I look at 12, I can skip count by 8, 16, 24, and I can skip count by 12, 12 and 24, and I can recognize that instead of going all the way to 96, 12 times 8 would get me to 96. And instead of doing that and having a 96 as my denominator, I can use 24 as my denominator, which is a factor of both of them, but not multiplying the two of them together. All right, so hopefully that makes sense to you. And I'm going to change that last color here, and I'm going to pause for just about 2 or 3 seconds here just to kind of get you guys to think about where do the 6 and 8, 6 and 12, and 6 and 7 belong. All right, hopefully you've had a chance to think about them a little bit. I know I kind of went quickly. I want to make sure I get through this video and have a little bit of time at the end to explain a few things. They're not in the same order as they were before. If we look at the red ones, it was A, B, C. If we look at the green ones, it was A, B, C. They changed the order up on us here. The one that goes with A in this case is actually 6 and 12. I can change a 6 into a 12 pretty easily by just multiplying 6 by 2, which means I can leave that 12 alone. I only have to change that one fraction. That's a really nice one to have, really easy one to have. Case B in this one actually is the last one on the list because the numbers, again, like I said, are one apart. 6 and 7, the only common denominator I'm going to come to with those two numbers is 42. 6 times 7. So that's going to be our case B. And then the last one here, 6 and 8, goes into category C, where if I skip count by 6 and I skip count by 8, I'm going to come across the number 24, which is 6 times 4 and 8 times 3, before I come across 48, which would be 6 times 8. So I'm creating a smaller denominator and easier numbers to work with. So hopefully that kind of just shows you different ways to find these denominators and kind of get us to think about the process that it doesn't always have to be, well, I see the two denominators, I'm going to multiply them together. Okay, we can look for how can we make these easier moving forward. All right, so here is what we are going to try and do now for question 2. We want to try to find, they call it the LCM here because it is the least common multiple, but we got to think of these in terms of denominators. We want to make them our common denominator. We want to make them the least. We want to work with small denominators. Okay, so our job here now is to create the smallest number possible using those two numbers. And in some cases it might be multiplying the two numbers together, and in some cases it might be changing one into the other, and in some cases it might be we have to skip count by both of them to find that first number we come across. So for number A, again, almost an example, if we go back here, I see a 4 and a 6. So we can kind of use our knowledge of that one already. That's going to be the one where we create our skip patterns, 4, 8, 12, 6, and 12. So my first number I come across on both lists is a 12. The LCM, or the lowest common multiple, between those two numbers is 12. I could get to 24, 4 times 6, but 12 is obviously smaller than that. If I go across now to B, 4 and 10. Okay, I can't change a 4 into a 10. Okay, I can't go 4, 8, 10. I can't skip count by a 4 and end up on a 10. I can't make that a factor of 10. But I can skip count by both those lists again and come up with a common number before I get to 4 times 10. Okay, I could use 40, but that's not the least common multiple. So as I look at 4 and 10, I can skip count to 4 by 5. 4 times 5 is 10, and so is 2 times 10. So my LCM for B should be a 20. C again is 6 and 8, which again we used as an example on the last or the top part of the page. So if you've got that written down, you can look back up there. Our LCM for that one should be a 24. Again, 6 times 4 is 24, and 8 times 3 is 24. Again, the more you know your multiplication facts, the easier these kinds of problems become. I can simply create skip counting patterns to figure that out, or I can use a multiplication chart, but the quicker and easier I understand number sense and these patterns, the multiplication facts, that's going to make these problems that much easier. All right, how about 6 and 9? I'm going to give you a little bit of time to think about that one. Again, I'll give you a hint. It is the same type as the first three were, where we are going to create a number that is not just multiplying 6 by 9. We are going to skip count by both numbers. Hopefully you're able to figure that out. 6 times 3 and 9 times 2 both get us to 18. So our LCM for that one, I'm not saying that 36 doesn't go into both of them. I'm not saying that 54 doesn't go into both of them, but the lowest common multiple, that smallest number that go into both, is 18. Okay, 6 and 10 is again same type of concept as we've been doing. You can see a pattern here. They're getting us to clearly think about these LCMs and not just saying, well, 6 and 10 has got to be 60. Could also be 30, right? 6 times 5 is 30. 3 times 10 is 30, but that is the first time that they cross paths. If I skip count by 6, I never end up on a number ending in a 0. The first time I end up with a number that goes into 6 is at 30 for my 10s. How about F? 8 and 10. Same type of thing. I could go with 80, okay, but if I skip count by 8s, I should come across to 40 before I get there. 8 times 5 is 40. 4 times 10 is 40. So I could go with 80 for my common denominator, but that makes some really large numbers, guys. And this is another example we did already, the 8 times 12, or the 8 and 12. Okay, 8 times 12 is 96. I don't want to use 96 as my common denominator, but if I start skip counting by 8s, or start thinking about my multiplication facts with 8s and my multiplication facts with 12, I should see that 24 appears on both of those lists. Okay, how about 9? 9 again, we're looking at 9, 18, 27, 36. Skip count by 12s. 12, 24, 36 is the first number I come across that appears on both lists. All right. So hopefully we are recognizing that as we go through there. Are there any questions with that? Or if there are any questions with that, I should say, please make sure you're checking in with your teacher as to how to find those. And we're not saying that you have to do it this way, guys, but the sooner you figure this out, that we can do that little bit of work up front and find the smallest denominator, it's going to make our problem easier, and we are going to pretty much guarantee ourselves that we won't have to simplify those fractions on the back end. Now again, think about, why do we come up with a common denominator? What is the importance of this? Why do I need to know this skill? Why are we hammering this so much on these last couple of lessons? Well, if we want to compare fractions, the easiest way is to have a common denominator. If we're going to add fractions, if we're going to subtract fractions, we have to have a common denominator. All right? And we really want to try to make sure that we are finding that simplest form before we get to the end of the problem, just to make our problems a little easier. All right? I'm going to pause right there. If you want to continue to practice I through L, go ahead and do that. There's actually a couple of different problems there that are slightly different than what we just did, especially question I. Okay, if you take, or L, excuse me, if you take a look at that one, it looks like an I to me at this point, but look at question L. That one is a different situation. If I skip count by 5, I skip count by 9, I'm going to find something unique about that one. All right? I will start a second video here very shortly, and I'll handle the rest of lesson 3.9. But if you have any questions on how to create a common denominator or how to find that least common multiple, make sure you check with your teacher.